Hello and welcome to the Data Engineering Podcast, the show about modern data management. When you're ready to build your next pipeline or you want to test out the project you hear about on the show, you'll need somewhere to deploy it, so check out our friends at Linode. With 200 gigabit private networking, scalable shared block storage, and a 40 gigabit public network, you get everything you need to run a fast, reliable, and bulletproof data platform. If you need global distribution, they've got that covered too with worldwide data centers, including new ones in Toronto and Mumbai. And for your machine learning workloads, they just announced dedicated CPU instances. Go to dataengineeringpodcast.com/Linode, that's Linode today to get a $20 credit and launch a new server in under a minute. And don't forget to thank them for their continued support of this show. This week's episode is also sponsored by Datacoral. They provide an AWS native, serverless data infrastructure that installs in your VPC. Datacoral helps data engineers build and manage the flow of data pipelines without having to manage any of their own infrastructure. Datacoral's customers report that their data engineers are able to spend 80% of their work time invested in data transformations rather than pipeline maintenance. Raghu Murthy, founder and CEO of Datacoral, built data infrastructures at Yahoo and Facebook, scaling from mere terabytes to petabytes of analytic data. He started Datacoral with the goal to make SQL the universal data programming language. Visit dataengineeringpodcast.com/Datacoral today to find out more. You listen to this show to learn and stay up to date with what's happening in databases, streaming platforms, big data, and everything else you need to know about modern data management. For even more opportunities to meet, listen, and learn from your peers, you don't want to miss out on this year's conference season. We have partnered with organizations such as Dataversity, Corinium Global Intelligence, Alluxio, and Data Council. Upcoming events include the combined events of the Data Architecture Summit and Graphorum, the Data Orchestration Summit, and Data Council in New York City. Go to dataengineeringpodcast.com/conferences today to learn more about these and other events and to take advantage of our partner discounts to save money when you register. Your host is Tobias Macy, and today I'm interviewing Dipti Borkar about data orchestration and how it helps in migrating data workloads to the cloud. So, Dipti, can you start by introducing yourself?
Yes. Hi, Tobias. This is Dipti. I'm the Vice President of Product and Marketing here at Alluxio, and great to be with you here today.
And do you remember how you first got involved in the area of data management?
Yes. So a fun fact about that, if you look at my initials, they're actually DB, database. And so I joke that I was actually born with that talent. But in reality, I was actually working on my master's thesis in the database lab at UC San Diego many, many years ago. I won't tell you how long. And that's kind of how I got interested in it. I started off writing kernel code for DB2 distributed for Linux, and I was there for many years. And then over time, moved in, the data management database space has emerged quite a bit over time. Structured data, unstructured, semi-structured data. I spent many years at Couchbase, a NoSQL database, MarkLogic, and at a GPU analytics company right before this. And Alluxio was very interesting because it kind of took the database in some ways, and each layer has now become its own layer. The query engine, you can think of it as Presto or Spark SQL. Alluxio is kind of like, buffer pool in some ways, and you have the storage engines. And so it still kind of kept me in that database path. And I got really interested in Alluxio given the cloud movement that we're seeing in the market as well.
Yeah, it's definitely interesting how a lot of the products that have previously been very vertically integrated have been starting to get sort of exploded into different projects where the database is getting exploded, as you said, into the query planning layer, and then the data storage layer is separate. And then also for things like ETL frameworks, where it used to be an end-to-end solution, those have been exploded into a programming layer that then sits on top of an execution substrate, and then the actual data that it's interfacing with is housed somewhere else. So it's definitely interesting how the cloud has just made us rethink the way that we build all these different applications and previously integrated stacks.
Yeah, absolutely. I think there's a big architectural shift. In some ways, people are calling it separation of compute and storage, but it's not just compute and storage, right? It's all the layers in the middle, and so with the cloud, the rise of the object stores, data silos increasing, data exploding in general. I think there's just such a need for new architectures that can manage this vastness of data we're still at the beginnings of, frankly. So it's a very interesting space to be in. And the challenge that we are dealing with at Aluxio obviously is being between compute and storage and enabling this separation and helping orchestrate data, making data more available and friendly, if you will, to the compute.
So we've touched on this term a couple of times as far as data orchestration. I'm wondering if you can give a bit of a description about how you define the term so that we can use that as a launching point for the rest of the conversation.
Yeah, sure, absolutely. So, what we say data orchestration is a method, a methodology of enabling data for the purposes of compute, and this has many different aspects bundled in. So, it's restoring data locality. Data locality is a big aspect of computing, and in these environments, it gets spread out, separated out. Data accessibility. How is the same data accessible in many different ways? It's going to be more important to the computational frameworks. And then finally, data elasticity. And then in some ways, it's a little bit like data virtualization, but it's a global namespace, a common way to access a range of silos of data that might live underneath. And so that's kind of how we think of data orchestration, as it's an enabler for compute to make data more available, more accessible, and elastic to compute.
There's another term that I've come across a few times that's data virtualization, and I'm wondering if you can give a bit of a comparison between data orchestration and data virtualization so that for anybody who happens to come across them later on can clearly understand what they're dealing with.
Absolutely. Yeah. So data virtualization in some ways isn't new because it's, whenever there are silos, you might need to abstract those, and there's a layer in the middle. It's a logical layer, if you will. It's a logical layer that allows you to abstract the data silos underneath. And that's really what data virtualization is. It's kind of the common namespace, a global namespace across those silos, be it relational databases, be it file systems, be it unstructured data. But orchestration, in some ways, is more than just data virtualization, because while you need the abstraction, and it's very important to abstract away where the physical data, the bits and bytes and blocks actually live, there are other aspects that become more important in this, as we talked about, disaggregated stack. When your, let's say, a Spark job is running in a cloud, and your data is in a remote S3 in a remote region or in HDFS on-prem, then you obviously need that abstraction because you don't want to deal with multiple storage systems, but you also need to pull your data closer to your compute, and you also need to make it available using the right APIs. And so that's where, in some ways, data virtualization is one of the elements of orchestration. But orchestration needs to be so much more, because once the data lands in a data lake, in a data silo, then it's going to be used and accessed in many different ways. It could be using a SQL-based query engine. It could be using a machine learning model that's based on a PyTorch or TensorFlow. There's so many ways to access data. And you want to optimize this data at the point of compute for the compute, as opposed to before it lands. And that's kind of what data orchestration is in some ways. It is, once the data lands, just land it somewhere in raw form, and then data orchestration is one of the tools available, along with data prep and so on, that can enable that data for the compute that the data scientist or a data analyst is using.
And obviously, Aluxio is one of the tools that fits into this overall category. I'm wondering if you can give a bit of an overview of the total landscape for tools that people might be familiar with. And for anybody who wants to dig deeper into what Aluxio is itself, I'll add a link to the show notes for the interview that I did previously on that.
Yeah, absolutely. Yeah, Aluxio is kind of one of those, one of the tools that represents data orchestration. In some ways, given that data locality or caching is one of the aspects, any cache that is enabling compute in some ways belongs to this category. We also see other projects in the Kubernetes space like Rook that are kind of positioning as storage orchestration. In some ways, it's similar. It's basically enabling a range of storage systems to talk to the computes on top. And so those are kind of some of the different tools that are coming up. We see a few other startups in the space as well that are focusing on orchestrating and caching and the data accessibility across different storage systems. So we see this as an emerging category, which will over time, in some ways, incorporate other capabilities as well. Right now, it's primarily locality through caching. We see that, or data virtualization in some ways through a global namespace, and then accessibility through a range of APIs, be it S3 or HDFS, so on.
So one of the use cases that we highlighted at the outset was the idea of cloud migration for people who have an on-premises infrastructure for their data storage and analytics that are trying to take advantage of the elasticity and services of the cloud. But I'm wondering if there are any other particular use cases that data orchestration is well suited for.
Yeah, absolutely. I think data orchestration is relevant in many different cases. And as I've talked with users and our customers, what we hear from them is that in the all cloud use case, if they're all in the cloud, right, then you're still in a separated environment. Your S3 is separate from your computes, and you can still pull in that data closer, or it might be in a remote region or a different cloud, right? If you are on-prem, then there's a couple of transitions that are happening today. So either users and enterprises are looking at migration to the cloud, which is an extremely daunting and challenging task, or they might be looking at offloading and moving to object storage on-prem as well, and those aren't as well suited for the analytical workloads. And so data orchestration could help with any of these. But let's take one example. So let's take an example of a migration scenario where a large enterprise has an existing HDFS deployment. Typically, it's a large cluster. It might be anywhere from 100 nodes to 2,000 nodes, and we almost always see that it's overloaded. Compute is heavily used and so on. And so they're looking for additional capacity, either to offload or, new things, new workloads need to be put somewhere else. And as data engineers, in some ways, look at this problem and try to solve this problem, they have a couple of options, right? They can continue to add more hardware, which becomes an expensive proposition. And I think people are trying to stop really investing on-prem and looking at other options. You can say, I can't run this any new jobs, which is not an option either. I can say, hey, let me schedule this some other time at night, or you can play around with optimizations. But if you need additional compute in the cloud, then there are a couple of approaches, right? You could do data copy by workload. So let's say you have a monthly report that you're running, or a particular Spark model that you want to run. And you do a mass copy, right, of this data into the cloud. Now you have two different copies. They might be out of sync. You run your job, and then you have to, figure out what part of that gets copied back and so on. So it's a fairly involved manual kind of error-prone process versus in the case of data orchestration, it's almost like a no copy zone. You don't want to create copies. It's like, copies create more problems than they solve in some ways. And so you want to use sync. You want to keep the data in sync with the core. So there should be just one master in some ways, and the data can be synced back and forth. And that's makes it easier for somebody to then burst their workload in the cloud. Data can still stay on-prem. The compute might be in the cloud, and then the data orchestration kind of syncs the data back and forth. And that's helps with taking one small step towards the cloud, as opposed to this massive migration, which can be, from what we hear, several years long process. So let me just pause there and see if Does that answer your question?
Yeah, definitely. And I'm wondering if you have any specific instances or an example topology of either a customer that you've worked with or a story that you've heard from people who are either using Alluxio or some of these other tools in the space to give a bit more of a concrete feel for somebody who is maybe still a little uncertain about how they might go about approaching this particular type of problem of having a constraint in terms of the amount of computer storage that they're able to access and then needing to be able to leverage some of these technologies to be able to expand their footprint and expand their capabilities.
Yeah, absolutely. Great question. So, actually, recently, a few weeks ago, I presented with a DBS Bank and Vitale from DBS Bank. We presented about this use case about hybrid cloud, and they have a large kind of storage system on prem where they're also running Alluxio with Spark and Presto on top. But more related with our discussion here, they were facing these limited capacity situations where there were new projects that were coming up. They needed to analyze data for new projects, and they just couldn't figure out how to do. The specific project that they started to look at was a call center project where they have hundreds of thousands of calls that come in. I think and over the year, even even more so annually. And there's transcripts, there's audio files, right? And all of this needs to be analyzed in terms of what are people calling in for, what are the problems, what is the root cause, can the customer experience be improved on, and they wanted to use machine learning to analyze this and figure out what these root causes were, to improve the experience. And so they looked at a stack on AWS with Amazon SageMaker that their data scientists used to actually write the models. The models then ran in PySpark on an AWS EMR cluster, and then Alluxio was feeding this EMR cluster the data which actually was coming from on-prem, and this was only in memory because as a bank, being the largest bank in Southeast Asia, they have a lot of restrictions about data in the cloud. PII information obviously cannot be moved over, but even if data is moved, it can only live in memory. Cannot be persisted. And so with this, all these restrictions, they essentially run Alluxio in memory, and they use it to sync data back and forth, the data that's needed to run this machine learning use case in the cloud. And as needed, they can burst their data, whether it's 100 nodes or 1,000 node cluster. It's very easy to get going because it's just a couple of clicks and it's very easy to get set up in the cloud. So no longer do you need to wait months for hardware to come in and so on. Capacity is elastic and on demand, and the compute scales elastically as well as the data tier, which becomes important. So that's kind of a real world example to give a little bit more context on how somebody could actually use data orchestration to do this bursting into the cloud.
So the obvious motivation for using cloud resources is that elasticity and the fact that you have a much shorter time cycle for being able to access that additional capacity. But what are some of the capabilities that you're giving up by using cloud resources in place of your on-premises compute and storage infrastructure?
Good question. So I think that you do have to be thoughtful, right? Because you have to go, the security paradigms are a little bit different for the cloud, and so you might need to be a little bit more familiar with those. So some of it might be skill, right? Acquiring new skills for the team, understanding the right protocols, the right authentication mechanisms, etc. Whether it's using AWS Active Directory on the cloud or something else, right? So I think that's one part of it. The second part of it is if you have, it's the services and the technologies are quite different in they're different services, right? At the end of the day, and if you have an on-prem model and it's a data center mindset, the mindset itself is a little bit different. There is you have to move from planning 2-3 years ahead, right, to just pay as you go, right? So there's quite a big difference in terms of the budgeting and the modeling that happens. It's so easy to run a large cluster and collect a big bill on AWS, that you could get into trouble. So there's obviously ways around that. With flexibility, comes great responsibility, and so you have to kind of plan for these things and think about these things ahead of time.
And there are a number of technologies as well that are coming out that make it possible to replicate some of the at least interfaces of cloud environments on physical hardware and on-premises infrastructure. And so I'm curious what you've seen as far as organizations trying to replicate some of that interface so to make it easier for when they do span to the cloud so that they don't have to modify or customize their application stack to be able to take advantage of, for instance, an S3 interface where they might be using MinIO on their on-premises infrastructure, or taking advantage of Kubernetes or maybe OpenStack for being able to have some of the flexibility of the cloud on their actual physical compute.
Yeah, absolutely. I mean, Kubernetes is extremely widespread. It definitely for stateless workloads. For stateful workloads, especially in a disaggregated stack, it's a little bit complicated, and actually data orchestration helps with that, because let's say you have data that's on-prem in a different environment, in different systems. Within Kubernetes, you still don't have a highly elastic data layer. And so you would have to, the data itself lives outside the Kubernetes cluster, right? And so actually we see Spark in Kubernetes, Presto in Kubernetes quite often, where they're trying to solve the data locality challenge within Kubernetes, and this is on-prem. And so we do see that coming up. I think over time the data driven workloads, or these kind of data intensive workloads, will get more productionized for Kubernetes. I think the stateless workloads like app servers were first, right? Then came kind of these operational databases that built use persistent volumes and built robust production ready environments using Kubernetes. The next kind of set of technologies is these data driven frameworks like Spark, Presto, etc. And we're just starting to see that people are trying them out, POCing them in early stages. Some are in production, but it's still early. And I think that Kubernetes obviously helps with that elasticity, getting that on prem, and it simplifies that problem. But at the end of the day, you still need the hardware to run it on, right? And so you will get a lot more flexibility, but the flexibility of the cloud in terms of having unlimited compute if you need it still exists. In terms of object storage, we definitely see a rise in the object store. S3 made object stores popular, whether they're in the cloud, especially in the cloud. On-prem, particularly as Hadoop gets disaggregated even more, HDFS workloads will slowly start moving towards object stores like MinIO, others as well. There's several out there, and the same thing will apply. You would need to kind of restore data locality on top of these object stores, which aren't really built for advanced analytics, and that we see that as one an upcoming or sort of an emerging use case that will come about maybe 6 months to a year down and become more prominent.
So you mentioned the specific instance of the work that DBS Bank is doing, but I'm wondering if there are any other common patterns that you've seen for cloud migration projects in the data and analytics space and some of the challenges that they present. And then also I'm wondering if you have any advice on useful metrics for being able to track and determine the overall completion and success criteria for the project.
Yeah, in terms of migration, we've seen a couple of different approaches. If the mindset is that the cloud initiatives in the enterprise are the paramount initiative, in the sense that like there's a immediate urgency to move to the cloud, really the only approach that works is migrating the entire data set to the cloud and then running workloads in the cloud, right? But it is a non-trivial it's a non-trivial kind of approach. Not everyone has the ability to run both on-prem and the cloud at the same time. It obviously doubles costs. But if that is an option, then we have, there are companies that just go about that way. Most of the companies, most of the enterprises, the way they think through it is workload by workload, right? And they start off with the low risk workloads, and these are workloads that don't need that might be ephemeral. So for example, you just run the workload and it's done and it's gone. They start off with the ephemeral workloads, then they start off with the more scheduled workloads that might be adding additional capacity, additional overhead at a certain time of the month. For example, at the end of the month, end of the quarter, there might be a lot more reporting jobs that run, and so those can be methodically moved over to the cloud. Their data sets can be moved over to the cloud. Now, if there is a huge overlap in the data sets across all these workloads, then it becomes harder, and that's where this the zero copy burst, or the bursting to the cloud, would make more sense. And so it depends on, these are the different approaches. It depends on the mindset of the company, the urgency of moving to the cloud, the goal of it, as well as the appetite, right? In some ways, there have been some breaches and so on, which has caused people to think about, okay, is this the right thing to do, especially with their enterprise data. And so what we hear is some data will continue to live on prem and it will never be moved to the cloud. A lot of data will move to the cloud, but there will be some kind of IP, almost IP category of data, which is so precious that it will continue to remain on prem. Now, the other part of the question you asked is metrics, right? So metrics in terms of how do you gauge success or progress through this process. At the highest level, there is total data set, the size of the total data set. But then you kind of come down to the next level of granularity, is the number of tables you're managing, and then you can look at that on a business unit basis, because invariably this data is split by finance and marketing and product, and it's everyone, all this data is in a single data lake or in a few different data lakes, right? And so you can go organization by organization, and within the organization, it's the number of tables that have been migrated or not, and then which reports are associated with those tables, right? So that you never are in a situation where if a report comes in, if a query comes in, that the data set is not available. There might be a period of time where you have to have both available, and then you're playing catch up. At one point, you say no more, no more new data gets generated, and then you start adding the new data, in the cloud, and then that workload permanently gets run in the cloud. So those are some of the things that we hear as we talk to users and try to identify workloads that they would like to burst or that would be easiest to begin with. Spark ephemeral jobs for particularly for machine learning, modeling, regression analysis, Monte Carlo analysis, those kind are relatively easy, and then you kind of move on from that point.
One of the other things that plays into some complexities of these migration efforts is that the cloud inherently requires a different approach to how you design and implement infrastructure and applications, because of the fact that a lot of the resources are ephemeral and there are no guarantees for durability unless you're talking about the storage layer in terms of like object storage or block storage. So I'm wondering what you have seen as far as pain points for companies who are going through these projects and trying to work on hybrid implementations or cloud migrations, and some of the ways that they approach employee education for being able to design and implement effective systems for these types of migrations and the goals that they have.
Yeah, I think that in most cases, in most scenarios, they look at they do it use case by use case, right? So they'll figure out, like in the case of DBS Bank, like we talked about, it was the call center project because there was a need. They knew that it would need probably significant amount of compute resources to run these workloads, and it might be non-trivial, right? And it affects the on-premise systems if you suddenly add a workload that's unpredictable. And so workloads that are unpredictable and where you don't necessarily know how much of an IO overhead or CPU overhead it's going to have on your existing system become kind of the first the first kind of category that they will start trying out of from, right? And then the program kind of begins from there, where new applications, they're, in many cases, they're really not allowed to be added to their existing on-prem Hadoop cluster. They just say, this is on data that's it's a specific data set. We don't have an additional compute capacity, so all new workloads on for this that satisfy this set of requirements, they will be run in the cloud. And so that's the first step. So is new workloads, new jobs move to the cloud, and then the moving the rest of it is the harder part, right? And so for that, you've got to have a very kind of thoughtful migration program, as we talked about earlier, to create a process from organization to organization, and run POCs even to see the implications, right? Because the first step as a platform organization, you're providing a service to other organizations, and because of that, you have to ensure that when your environment changes, it's not going to have it's going to be at least as good, right? And so performance becomes a criteria, feature set becomes a criteria, and security, the level of security, though, that becomes a criteria. And so based on that, you create the migration program to figure out what can be burst immediately, or what needs to be physically moved over, and use a more of a lift and shift approach.
And we've highlighted a few different tools in the data orchestration space in the form of Alluxio and Presto and Spark, etc. But I'm wondering what you see as being some of the missing pieces or gaps in the landscape where there's an opportunity for either extending some of the existing tools or building a new tool or platform to fill that particular gap, and any efforts that you're seeing on those fronts.
Yeah, good question. We have been, as a product person, I'm constantly looking for exactly this. Where are the gaps, and how can we fill them? Obviously, from an Alluxio perspective, but also broader than that. And what we're seeing is that the world of advanced analytics, in the Hadoop world, it moved to files, right? So everything is kind of a Parquet file, ORC file. It's a file-based approach as opposed to a tables-based approach. And what this means is that you're kind of dependent on the Hive Metastore, or the catalogs like that, to be able to do anything. So Presto, for example, needs it. Spark SQL would need it. And so there's an interesting space there where there are projects emerging like Iceberg and so on, where you can actually get the schema out of your Parquet files, and do things more efficiently and optimize. And so I think that space is ripe and it'll evolve. And, we're thinking about that as well. In fact, we might have some fun announcements at our data orchestration summit that's coming up, that we're hosting in November 7th. And so that might be one of the areas. The other area I see that's interesting is data transformation as well. So one is the catalog services. How do you manage structured metadata in a land of files and objects, right? The second one is more around transformation, where up until now, what was happening is that when you move data from a really operational system, your OLTP system, you would go through this ETL process and prep it, convert it to a star schema, and kind of do the optimizations beforehand, and then land it in your data warehouse. And then you would just query it, right? And then that was the holy grail, was the star schema, Snowflake schema, and so on. Then now what's happening is there's so much data that it's somehow just landing, right? It's landing in the data warehouse or the data lake. And so instead of spending time optimizing before it lands, you might want to do some event-driven processing like Kafka, kind of event-based analysis beforehand. But the optimization of how the data is stored itself is no longer as important, because you're not depending on a star scheme as such anymore. And so the optimization for the transformation needs to happen after it lands. And so what we see is that you will actually optimize on the way to compute. So when compute needs the data, that's where it needs to be optimized on demand and convert it. If it could be a better file format, you convert it to a better file format. If it needs to be compressed, you can compress it. If it needs to be coalesced, you can coalesce all the files. And so the prep and the transformation will actually happen on demand as you're consuming it. And I think there's interesting things that can be done in that space that we're looking at as well. But beyond Deluxio, I think there will be a lot more optimization that happens for the compute, to from a performance perspective, because every compute is different, and every compute favors different formats and different approaches and compression techniques and so on. So I think that's another space where we will see a lot more automation. So less manual work, a lot more automation, and more tools will come up.
And what are some of the overall industry and market trends that are both driving the overall data orchestration movement, as well as some of the ways that data orchestration fits into those broader ideas? And what are some of the particular projects or trends that you are personally most excited by?
Yeah. So, as we started off, actually, the conversation, we started talking about how it's become more disaggregated. And so, the trend of a separated storage and computer disaggregated stack, I think that will continue. And, there might be some tightly vertically integrated systems, but large majority of platform teams will use disaggregated architectures. And that's certainly pushing and driving data orchestration. Another one along those lines is just self service data, and making data analysts and data scientists a lot more efficient by giving them access to the data whenever and wherever they need it. And I think that's another one that's helping that, vice versa, right? Data orchestration enables it, and the trend also helps make data orchestration more real. And then, in terms of the other question you asked was around, I think the what I'm most excited about, right? The trends and so on. So I think that the data revolution is kind of at the beginnings. We're just now, we've gone through this Hadoop ecosystem, many iterations of it, where we went through MapReduce to Hive to Spark SQL to Presto. There will be constant innovation that happens on the framework side. I think that moving to the cloud, the resources available in the cloud, the flexibilities of the cloud will enable a new range of a new set of innovations to get insights from data significantly faster. And so, because of these operational efficiencies, time to value and time to insight will be significantly faster. It could be, using GPUs more efficiently and at scale. It can be query engines that are highly distributed at scale. And I think that there's this entire kind of data ecosystem will continue to emerge as it has. And if you look back, you still see that mainframes are still around and Teradata is still around, and but at the same time, the amount of data and the capabilities that data has is just exploding. So continue to be very excited in this space, and in some ways continue living up to my initials.
So, for somebody who wants to learn more about the overall space of data orchestration and the benefits that it can provide, and some of the overall industry trends that it's driving that are driving it, what are some of the resources that you would recommend?
Yeah, absolutely. So Aluxio is an open source project, and so actually we have a lot of information openly available on our sites, and it's free down to download, community edition. We also have we are putting together a data orchestration summit that is planned for November the 7th, and it's a great lineup of speakers. We have thought leaders from Netflix, from O'Reilly, DBS Bank, Walmart coming in to present, and we actually have a special offer, I think, as well. So you can use the code podcast for 25% off on our registration. And the Data Orchestration Summit will help you understand not just about Alluxio, a little bit more about Alluxio, but the other data engineering tools that are out there that can improve the efficiency and help these unsung heroes that are the data engineers.
And are there any other aspects of data orchestration or hybrid cloud and cloud migration projects that we didn't discuss yet that you'd like to cover before we close out the show?
I think we talked about a lot. So yeah, it was a great conversation. We can all, we have a lot of information on our website and so on. And personally, looking forward to seeing folks at the summit. So thanks so much for having me on, Tobias.
And for anybody who wants to follow along with the work that you're doing or get in touch, I'll have you add your preferred contact information to the show notes. So as a final question, I'd just like to get your perspective on what you see as being the biggest gap in the tooling or technology that's available for data management today.
All right. The hardest question at the end, huh? I think that there are many gaps. We talked about some of them. I think metadata management in general across structured and unstructured data is something that needs to be tackled a lot more. At the end of the day, the value and the insight of the data is in the metadata. A lot more lineage and tracking and really leveraging of metadata can be done across the enterprise, and it's not a hard it's a very hard problem to solve, and it's being solved in silos today. And it'll be interesting to see how that space emerges and that gap closes, because at the end of the day, if you access data, if you manage data, you kind of have to have access to the metadata first, and I think that's something that will need to be solved in the short term. Yeah, and there's obviously others out there, other gaps that will emerge, and innovation will continue. Yeah.
Well, thank you very much for taking the time today to join me and share your thoughts on the space of data orchestration and some of the ways that it can have some concrete benefits. So thank you for all of your time and effort on that, and I hope you enjoy the rest of your day.
Absolutely. Thanks so much. Bye-bye.
Listening. Don't forget to check out our other show, podcast.init, at pythonpodcast.com to learn about the Python language, its community, and the innovative ways it is being used. And visit the site at dataengineeringpodcast.com to subscribe to the show, sign up for the mailing list, and read the show notes. If you've learned something or tried out a project from the show, then tell us about it. Email hosts at dataengineeringpodcast.com with your story. And to help other people find the show, please leave a review on iTunes and tell your friends and coworkers.